Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of using the Pythagorean Theorem. This is standard 8.7c in the great state of Texas, and we are using item number 38 off the 2019 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have the length of a rectangular frame is 15 inches, and the width is 8. We need to find the length of the diagonal, and we don't have any answer selections to choose from, no F, G, H, or J to make sure we are correct. All right, so let's just kind of draw something so we have something to look at here. So here is my rectangular frame. Looks like I've got my 15 inches right here, and I've got my 8 inches across the top. Now I'm looking for the length of the diagonal. All right, so my diagonal is going to be here. When I do that, you should notice that I have made two different right triangles. And when I see different right triangles, I should be thinking of my Pythagorean theorem. All right, so my Pythagorean theorem says a squared plus b squared equals c squared. It's very helpful for finding side lengths of a right triangle. It has to be a right triangle. Now, what exactly does this mean? Well, when we're looking at a right triangle, we've got two different sides that are connected to the right angle, this one and this one. They're the shorter sides, and we call them A and B. Those are just the names we call them, and they're each called a leg. So A and B are the two different legs. They form the right angle right here. Across from the right angle is always going to be the side that we call C. So A, B, and C. C is always this other side over here called the hypotenuse. And what this a squared plus b squared equals c squared means is if we were to actually make each of these into squares, and I put it too close to the side of the screen, so pretend that's a full square, right? And if we were to take the whole area of that, well, that would be a times a, or a squared. So that's the area of that. Take the area of this b right here, which the area would be b times b, so that's your b squared. And if you add those two, a squared plus b squared, the area of those two squares always equals the area of the square that would come off the hypotenuse, the c squared. No matter the size of the right triangle, a squared plus b squared always equals c squared. So that's a constant that we know. It's very helpful. So let's plug some of these numbers in. So I'm looking for c, so I need to isolate that variable. Well, I know that a is 15. All right, so 15 squared plus b is going to be 8, so 8 squared equals, and then there's my c squared. All right, so let's just do a little bit of squaring and adding. So my 15 squared, that's 15 times 15, that is not 15 times 2. So that's 225. And then I've got my 8 times 8, not 8 times 2, that's 64. So 225 divided or added to 64, not division, it's going to get you 289. All right, so 289 equals c squared. Now, there is no F, G, H, or J. We're going to have to bubble this in, but what we're not going to do is we're not going to put 289. We have not isolated the variable yet. It still has an exponent. It is c squared. This whole area right here is 289 inches squared. I just want the side length right here. So the only thing keeping that c from being completely isolated is this exponent. It's c squared, or c times c. And so the only way that we can get rid of that exponent is to take a root. So since I squared it, I'm going to take the square root of both sides. Exponents and square roots cancel each other out, so that's going to equal c. So my question is, what is the square root of 289? We use our calculators on that, and you're going to get a nice even integer, 17. So now we just got to bubble it in. But that's not too difficult. We're not going to put anything in the 2 digits to the right of the decimal. We're just going to put our 17 into the tens and the ones place. There's our answer.